So guys, in the last video we have discussed about different families of the collections. What is list family, what is queue family, what is set family, right? Now and what is collections and iterable and all. Now let's discuss what are the different classes, why there are different classes, what are the difference between array list, linked list and all, why there are multiple classes they have implemented under each and every family. So first of all, when we should go by the list family in collections, when you want the way you are adding the element, the order should be maintained, then we should go with the list family. Correct? And also you want the duplicate elements should be allowed, then you should go by the list family. So you want the element to be stored in proper order and duplicate elements also should be allowed, then we should go by the list family. For example, if I am entering X, then Y, Z, it should store. First index it should be X, then next it will be Y, next it will be Z. If I again want to enter X, again X should be entered in the fourth position. So I can enter duplicate elements as well as the way in the sequence, the way I am entering, it is going to store in that sequence. Then we should go by the list. Then what is array list? How to declare it? So let's see, I can declare like this, list L equal to new array list, correct? Or I can declare array list L equal to new array list. In both the way I can declare, right? Now what is the difference between declaring in this way and this way? That already I have explained in the interface class. You can go through in interface video. Correct? I can declare in any one of the way, right? You can create the object reference from the interface, or you can create for the class object reference only, and you can create the object of the class. And you can't create an object of an interface list, which you can't do. Right? So this is the two way I can declare. Now, couple of points you need to be remember. I have noted down some points, so make sure. Underlying data structure of the array list is resizable array. Okay, that means you can, the underlying data structure is resizable array. Means it can change its size. So when you declare the array list, the default capacity of the array list is 10. What is the default capacity? 10. But it is not going to occupy all the memory. See, if I write L.size, if I write L.size and if I print it, see the output, it's showing me 0, the size is 0. Means it's not going to occupy any memory until and unless you enter some value. Okay, so the size is 0. Though the initial capacity is 10. So initial capacity of the array list is 10 as soon as you declare any array list. Okay, so see, I am adding the value L.add. I am adding some value L.add. I am adding some value here. Okay, I have added two values. If I run it, see the size is 2. Can you see, though the initial capacity is 10, it's not going to occupy all the memory. Whenever you enter any value, it's going to occupy the memory. So I'm entering, say, GG. Here I am entering HH, right? Again, here I am entering QQ. If I run, what is the size? 5, because there are 5 elements. If I enter again BB, and if I run it, the size is 6. So BB is already entered, I have entered. So duplicates are allowed in the array list. Okay, duplicate elements you can enter. Even the elements are storing in proper order. So first element is in the 0th index, second one will be the 1, 2, 3, 4 and so on. If I want to print L.get, you write the index, I am writing 1. If I run it, it's printing BB, can you see? If I write 4, means 1, 0, 1, 2, 3, 4, it should be QQ. Can you see? I am entering in the way I am entering, it is maintaining the sequence, it's storing in the proper sequence. Okay, If I want to print everything, what I can do, I can create a for loop, correct? For integer I equals to 0, I less than L dot size, right? I plus plus. This for loop you already know, I have explained in the array class also. Here I can write L dot get I. If I run it, you can see it's printing all the elements A, B, G, H, Q, B. Got it? So it's maintaining the proper sequence. You can see it is, displaying in the proper sequence. Clear? Proper sequence should be maintained in case of ArrayList. Now, for example, if I enter 11th element, what will be the size? If you enter the 11th element, the next size will be current capacity into 3 by 2 plus 1. Okay, what is the current capacity? Current capacity is 10. It will be 10 into 3 by 2 plus 1. Means 10 divided by 2, 5 into 3, 15 plus 1 is 16. So second, the capacity will be 16. Up to 9th element, up to 10th element, if you enter, 0 up to 1 to 10 element, if you enter, the size will be 10. The capacity will be 10 of this array list. Okay, the capacity of this array list will be 10. Whenever you enter 11th element, so this is underlying data structure. What is that? Underlying data structure is resizable array. Means it can expand automatically. So how it is going to expand? I have implemented in like this way. If you enter the 11th element, that size will be 10 into 3 by 2, okay, plus 1, which is nothing but equal to 16. Now, if you enter 11th element, 12th element, 13th element, 14th, 15th, 16th element, up to 16th element, the size will be 16. As soon as you enter 17th element, what will be the size? Size will be 16 into 3 by 2 plus 1, which is nothing but 25. So like this, it is going to increase the size, increase the capacity. But it is not going to occupy all the memory. That's what you saw, right? When I entered one element, the size is 1. If I enter 2 elements, size will be 2 and B. So this is the capacity. So it doesn't mean it's going to occupy all the memory. Okay, so that is what is array list. You can declare an array list and you can keep on adding the elements. If you want, okay, system.out.println, and I am just writing L. It will print all the elements. Instead of writing the for loop, you can just write the L. It will show you. I can write L dot remove. You can remove an index also. Like I want to remove 3. I am again printing the value of L. If I run it, see, it means H. 0, 1, 2, 3. There is no H here. I have removed it. I want to add also. L dot add. Now you can add into a particular index also. I want to add in the 4th index. What element I want to add? I want to add maybe small a. Okay, in the 4th index, I am adding the small a. So if I paste it here and run it, the 4th position means 5th position. Index 4 means 5th position, right? 0, 1, 2, 3, 4. Index 4, because index starts from 0. So 4 means in the 5th position. It is entering AA. Got it? You can add, you can remove, and all these things. So initial capacity, underlying data structure is, remember, resizable array. Initial capacity is 10. Once you enter the value, if you enter the 11th value, the next capacity will be current capacity into 3 by 2 plus 1, that is 16. Once you enter the 17th element, the next will be 16th into 3 by 2 plus 1, 25. If you enter 26th element, the next capacity will be 26 into 3 by 2 plus 1, like this. Okay, so this is what is that's how ArrayList is going to increase its size, and the underlying data structure is resizable array. Now, when we should go for an ArrayList? Now, think about it. You are performing some operation. What kind of operation you can do? You can retrieve any value, right? Say this is your ArrayList, for example. Here, first element, second element, third element, dot, so on. You have up to 1 million record. Maybe here 1 million element. So the best operation is ArrayList is retrieval. If you want to retrieve any value, if you want to retrieve the first value, what you will do? You have to write like this, right? L dot get 1. As soon as you write L dot get 1, it will retrieve the first element, it will return you 1. If I want to retrieve the third element, L dot get 2. Right? First element will be L dot get 0. Index starts from 0, 0, 1, 2, dot, and this is the record. So if I want to enter, say, some element in between, I'll just write L dot get and I'll write the index. So whenever you write the index, it will directly retrieve this element. So if the first element takes, say, 0.01 millisecond to retrieve, second element, when you retrieve the second element, it also will take the same time. Third element also will take the same time. Even the nth element will also take the same time, or even the 1 million. If you have 1 million record, if you are retrieving the last record also, it is going to take the same time, because it will not go one by one. It will directly go to that and it will retrieve the element and it will give you the result at the same. It is going to take the same time, the last element and first element or any element. So whenever you are performing any retrieval operation, the array list is the best choice. Then when we should not go with the array list? Think about it. I am adding some element or I am removing some element. What will happen? So this is my array list, right? Now there are different elements are available here. Dot. Lot of elements are available. If so, here is the 0 position, 1 position, 2, 3, dot. Here may be, say, 1 lakh position. Now I am adding some element in the, say, 4th position. What I will do? It will enter here. Maybe I am entering X here. When I enter X here, what will happen? Whatever is there in the earlier, whatever is there in the 4th position, it will go to the next position, right? 5th position. So 5th position, whatever the element was there, it will go to the 6th position. 6th position, whatever the element was there, it will go to the 7th position. Like this, each and every element I have to move one position, the right. Anyway, if I want to delete some operation, if I want to remove something, if I remove this, say for example, if I am going to remove this, what will happen? This here, whatever the value was there, it will move here. The value whatever was there in this, it will move here. The value whatever was there in this, it will move here. So every element will move one, left side, one block. Same way, last position, last value also have to remove one position. So if there are 1 billion record, just think about it. 1 billion record need to shift either left or right based on your add or delete operation. So whenever you are performing any retrieval or insertion operation, ArrayList is not the best choice. Because every operation, every element need to move right or left. If you have 1 billion record, if you are inserting something, maybe all the records to move to its change its position might take 1 or 2 days. After running this add, you might need to wait for 1 day or 2 days if there are billions of records. Because every element need to shift either left side or right side. So that's what I have mentioned here. If you see, if the frequent operation is retrieval, ArrayList is the best, because we can retrieve by using index directly. If the frequent operation is add or remove, ArrayList is the worst, because every element need to move. The underlying data structure is resizable array, as I told you. Okay, here already I have mentioned. Default size is 0. If you enter 11th element, new size will be like this. Okay, so remember these are the points. Second is ArrayList is synchronized. Synchronized means what? Multiple threads can work at a time. So multiple threads are allowed. Means you have some independent operation, all can work parallelly in the ArrayList. So the performance wise, it is very good. But if it is performance wise good, it is not thread safety, right? It is not safe, because multiple processors are working together in the single processor. So it is not safe. There might be, something might happen also. Some out of memory or anything you might get it. So whenever there is a multiple threads are allowed, so those things will not be thread safety, but performance wise it will be too good, right? There are hundreds of operations, all are independent. If all are running in the parallel, the performance definitely will be really good. Okay, so remember ArrayList is synchronized, so multiple threads are allowed, so performance is good, but it is not thread safety. So remember all this point if someone asks you what about ArrayList. Clear? How to add, remove, and delete. Now, for example, the ArrayList you have 100 elements. Okay, I deleted. You have 100 elements. You have to enter. Now, if you declare like this, what is the initial capacity? 10. Now, if you enter 11th element, it will be take 16. When you enter 17th element, it will be 25 like this. But there are 100 elements. So you can declare an array list. Okay, there is one more constructor where you can enter the capacity also. You can declare 100. So it will create an array list with the capacity of 100. You can initialize the capacity also. Instead of using default 10 capacity, you can change the capacity also. But see, size will be 0, right? It is not going to, it is not going to occupy the memory. So here if I write L2, and here if I print L2 also, if I run it, you can see size is 0. There is no element, but capacity is 100. So like this, you have 1 lakh element, you can enter 1 lakh capacity. Okay, that is one more constructor in the array list where you can enter the capacity and you can decide the capacity of the array list. Third, you can declare one more way, array list. Here you can pass any collection object. Okay, you can pass any collection object. Collection C. When you have to use it, for example, you have some set, you need to convert into an array list. You can go ahead with this. For example, just an example. Okay, I'll talk about hash set later. Just wanted to show you hash set h equal to new hash set. So I have a hash set, right? Now I can add some elements and all in the hash set. I want to convert it into an array list. What I can do? I can just write. Okay. Rename L2. Why? Okay, there is already one L2. So I can rename. Can you see? So whatever the elements will be there into the H, you can add a lot of elements. Then later you can convert it into an array list also. So using this constructor, any other collection object you can convert into an array list. So there are a lot of collection objects, right? Hash set and all, tree set, vector and all, link set. If you want to convert into an array list, you can use this constructor. You just pass the object of that, class of that, collections. So it will be converted into an array list. So these three constructor are available in the array list. This is the one. You can convert any collection object into an array list. Second, you can define the initial capacity. And third one, you can declare like this, okay, without passing any input argument in the constructor. By default, it will take the capacity as 10. Okay, and remember all these points. That's what the array list is. Okay, thank you.